Hello again, we're in chapter 2 now, and we're going to talk about rectangular coordinates and graphs. And most of it will be pretty simple, I hope. But there are some things you need to be careful about, and I'm going to try to set you straight on those. There's the list again. Sorry, I have there twice. The ordered pair, 2 components. It does make a difference which one's first and which one's second, of course. And they're written inside parentheses. Here's an example coming up. And we've got ordered pairs here too. The category is the first coordinate. The amount spent is the second coordinate. So one example, if we take the first line, is food is the first coordinate, and 7729 is the second coordinate, covered by or enclosed by parentheses. And perhaps you want to put the dollars in there too. You probably won't, but you could. So for the housing, what would it be? Housing, 19884. Entertainment. See where that is? It's at the bottom. And there's your ordered pair. It's that easy. Now here's an extra one I threw in that wasn't with the book, but it is a good tip. If you go to mathbits.org, it's on the internet, on the web, scroll down the page, about 1 page worth. And on the right side, you'll see this, and this is downloadable graph paper. And you have, as you see, 31 choices of graph paper. Now these are in addition to what I already put in Blackboard. If you like the one you have in Blackboard, that's fine. If you'd like something just a little bit different, you've got a lot of choices, including some you probably don't want, like polar graph paper. Unlikely. You also have some things about the TI-84 here and the TI-Inspire. You might want to check that out. Don't worry about the TI-89. I doubt that anyone will have that, although it's possible. So, coordinates of ordered pairs. This is the rectangular coordinate system here, also known as the Cartesian coordinate system. Every ordered pair of numbers corresponds to a point on this plane. This is point -43, 0.83, 0.8, -2. Each one of the sides has a length. And the distance is just the difference between the two x coordinates, or the difference between the two y coordinates. And if you happen to end up with a negative, you turn it to positive, because distances are always non-negative. Now the Pythagorean theorem helps us find out what that missing side of the triangle is. Subtracting the x coordinates will give us this distance right here, the distance for the x coordinates. Over here we can get the distance for the y coordinates, but what about this? Well, the Pythagorean theorem helps us here. This distance and this distance. What's the other distance? This is called the hypotenuse, and the connection, which you've probably heard of before, is if you square the x distance, square the y distance, add them together, you get the square of the hypotenuse. So this squared plus this squared equals this distance squared. So the distance between those 2 points P and R is 13. Here is the formula for that. the general formula for the distance between 2 points. Now, a couple of things to notice. First of all, in this set of parentheses, you're subtracting x coordinates. Don't mix up the x's and the y's. It's just the x's. After you subtract them, you square it. Then you go to the y coordinates. Find the difference, and then square that. Add them together, and then take the square root. And that will give you the distance between P and R. P and R. So here's one to add to your notes. The distance from P to R, and you can see it right there. Now the 2 and the 1 just mean that you've labeled one of those points as point 1 and the other one as point 2. It doesn't matter which you do. The important thing is you follow this. Follow each subtraction by squaring, the squares by adding, and then finally take the square root of the answer. So here's one you can try. You might hit pause and see if you can do this by yourself. Okay, you're back. I hope you tried this. So here we're subtracting the x coordinates. And notice that this point is referred to as the second point for obvious reasons. P to Q, P comes first in the alphabet, so make that second, and this the first one. So this would be x sub 1, y sub 1 in this ordered pair, and x sub 2, y sub 2 in this ordered pair. And just follow the directions. If it comes out even, that is fantastic. If it doesn't, then this is the exact value. Now it doesn't come out to be an integer, which is unfortunate, but this is the exact answer. If you want the approximate answer, use your calculator and use the correct number of decimal places afterward. So the sides are called A and B. The hypotenuse is called C, and the Pythagorean theorem is A squared plus B squared equals C squared. Now, how you find out whether you've got a right triangle or not? Well, the Pythagorean theorem refers to right triangles, and it goes both ways. If you've got a right triangle, you can find the hypotenuse with the Pythagorean theorem. If you're not sure whether you have a right triangle, you can take these three sides 2 at a time. So take these two, find the distance from M to Q, and take these two, the distance from M to N, and finally the distance from N to Q, or vice versa. Now what you'll do is you'll square these three and see if 2 of the squares add to the other one. If that's the case, then you've got a right triangle. So here we go. This refers to finding the distance from M to N, or vice versa. And here's our formula from the Pythagorean theorem. And the distance is the square root of 200. You might want to write that in. M to N, square root of 200. M to Q. Good practice. That way you are less likely to make a mistake. That gives you the square root of 400. And that's from M to Q. Square root of 400 there. Remember, this was the square root of 200. And then get the other one. Now that one comes out even. That's nice. From N to Q, it's from here to here. And if you do the math, you get the square root of 200. Now the question is this squared plus this squared give you this distance squared on the hypotenuse? There's our square root of 200 for N to Q. And sure enough, squares of two of them equal the square of the third one. Next, how can you tell if the points are collinear? Is that a new word to you? All it means is they're all in the same line. How do you figure that is? Well, the 3 points are collinear if you add two of the distances and they're equal to the distance between the third. Sort of like this. If you had a point here, a point here, and a point here. These points would be on a straight line if you can add that distance to this distance and you get that distance. Here's one you can practice with. I suggest you go back maybe or listen to that again. See if you can determine whether they're collinear or not. Get the three distances, see if two of them add to the third one. This first one, second one, third one. And this third one, if you notice, is the sum of these first two ones. And that makes the 3 points collinear. Now, this is a different one. This is the midpoint formula. Now, remember the distance between 2 points you find like this. x1 minus x2 or vice versa squared plus y1 minus y2 squared. Notice you're subtracting here and you're squaring. You're not dividing, and you take the square root. To find the midpoint between these 2 points, you take the x coordinates, add them together, divide by 2. You're finding what is the middle coordinate to x1 and x2. Same thing with the y coordinate. Add the y1 and y2, divide by 2, and there are your coordinates for the midpoint. So let's take an example here. We've got 2 points, and just imagine that you're traveling from this point to that point. Where would you be halfway? Here's the midpoint formula. Add the x coordinates, divide by 2. Add the y coordinates, divide by 2. Remember, you don't subtract, you don't square, but you do divide by 2 for each one. And there's your midpoint. Halfway from here to here is that point right there. 1 negative 3/2 or 1 negative 1 1/2. Try this one. You got 2 points. Find the midpoint. Pause the video. Give it a shot. You got the formula right in front of you. You shouldn't make a mistake. Okay, I hope you tried it and you're back. Now for this one, we're going to have to use the midpoint formula twice. Remember, this is a little bit different. you've got an endpoint, an endpoint, and a midpoint. One of the endpoints is given, and the midpoint is given. You're missing the first point. So start with this, put the part of this you know, let's call that negative 6, 12. We'll call that x sub 1, y sub 1, and then you can figure out what x sub 2 and y sub 2 are. Like this. There's from point P, and there's the coordinate of the x coordinate for the midpoint, 22. Try that for the y. Add the y coordinate you know to the one from the midpoint, divide by 2, solve that simple equation, and there's the y coordinate for that endpoint, 22. Negative 16 is the missing endpoint. Next, let's take a look at a graph. Now we've got a fast food restaurant. You can name it whatever you like. Name it after yourself. Why not? You've got a couple excuse me, got a couple of ordered pairs. You might want to put the, excuse me a second. Okay, I'm back. This is similar to what you can do if one of the lectures gets longer, you get interrupted. Hit the pause button and come back. So it's a good example. So here, and as I mentioned, this is an ordered pair. There. Now what you might have is you might want to put the year first. So 2011, put that as the first coordinate, 2017 as the first coordinate, and put the numbers for your second coordinate. Now what you want to do is use the midpoint formula and estimate the sales for the year 2014, which is halfway between 2011 and 2017. See what you get for the midpoint and then compare it with $195.4 billion. So there's a little picture to give you an idea of this fast food restaurant. Here 2011, 2017, and the amount sold in those 2 years. You want to find out how high this graph is in 2014, which would be halfway. Now, there is a trick you can do. So let's take the first one, for example. You could have the ordered pair 2011 and 167.7. So you can leave off the dollars temporarily and write the year. Now, the trick you can do is, if you can say X is years since 2011, then you can write this as 0 years since 2011, and 167.7, and the other one, since 2017 is 6 years later, your order pair would be 16 to 33.7. The numbers are a little bit easier to work with, and you'll be looking for what the sales figures are for halfway in between. Now, this is one way of doing it. Remember, you could make the years different. You could make them 0 and 6. You could also make them 11 and 17, saying it's X represents the number of years since 2000. Whatever strikes you at the time. And there's how you find your midpoint. Notice that these are the x coordinates. You're adding them, and then you're dividing by 2 to get the first coordinate. And in this one, here are the y coordinates. You're adding them, dividing by 2, and that's your estimate for what the sales figures were in 2014. It's not quite the same, but it's not too far off. Next, we want to find 3 ordered pairs or solutions to this. And what you can do is choose, and this is real, choose any real number at all for the x. Put that number in where you see the x here, and all you have to do is some simple calculation to get the y coordinate that matches up with it. So, for example, let's suppose I choose 1 for the x. If I put that 1 in where the x is, I have 4 times 1 is 4, minus 1 is 3. There's one ordered pair. If you put 0 in for x, you get a negative 1 for y. If you put a 2 in for x, 4 times 2 is 8, minus 1, 7, you got 3 ordered pairs. And you can graph those, connect them with a straight line, and you can see what that looks like visually. The person who made these slides did a little bit differently, but it's the same thing basically. You want 3 points. That gives you 1 point, negative 2, negative 9. The second one, you're going to let the y be 3. You can figure out what x goes along with it. It's a 1. So this point over here was in negative 2, negative 9, and this point, remember this is the y value, 3 and 1. And there are your points. It's also called a solution. They're points on the graph. This one, I hope, doesn't throw you off too badly, but you still want to do the same thing. You want to order the pairs. Now, if you're crafty, you're going to pick y values that after you subtract 1, you have a perfect square. That makes things much easier. So if we let x be a 1, we can solve for y. Square both sides, pretty simple. Add 1 to both sides, and the y coordinate is 1. So you got an ordered pair. The x was a 1, and the y that went along with it was a 2. There you got an ordered pair. And you can also do that finding points like 0, 1, and 2, 5, because they will make this a true statement that makes them solutions. Now for this one, you got a square. Now one thing you should know when you have a square or a square root or a cube root somewhere in there, it's not going to be a straight line. And you're going to need more than 3 points. You're going to need maybe 5, maybe even more. Start with about 5 and then see if you need more to fill in so you can smooth in the curve. Here are 5. Just choose any x's you want. Square, subtract 4, you get the y coordinate that goes along with the x coordinate. There are your ordered pairs. Now if you want to graph the equation, this makes it easy. First find the intercepts. Now what does that mean? Real quickly I can tell you the intercepts are where the x is 0 and you'll have to find the y. And where the y is 0, you'll have to find the x that goes along with that. find some additional ones. These are easy because of the zeros. Plot some other ones and connect the points with smooth line or curve depending on what the equation tells you. Now you can take a look at this. You want to graph it? Use some of the graph paper I sent you or some from the internet site that I showed you. Remember, make a small table for yourself. Now notice that x is x to the first and y is y to the first. And that tells you right away this is going to be a straight line. So all you need are 3 points, and you can pick anything at all for the x's. For example, I might pick -2, 0, and 1. Now why did I pick those? Well, typically if I'm graphing, I'll pick a negative number or maybe several. I'll use 0 if possible, and I'll use another number that's positive or several that are positive. It all depends on the equation, which x's you'll actually want to explore. So let y be 0 to get the x-intercept. You might want to remember this, write this down. Let y equal 0 to get the x-intercept, and let x equal 0 to find the y-intercept. So you'll have points like this, x and y. You want to find 0 here, what goes along with it in the y. Put 0 here and find out what x goes along with it. That gives you 2 good points, 2 points that are usually easy to figure out. And then you'll have to find some other points. Pick another x, maybe 5, -3, let's say 1, whatever you want really. It's a straight line, you can tell, so you can pick any x you want. So the intercepts are found. There's the x-intercept. There's the y-intercept. Easy to graph. Some other ones. Put something else in for x, like a -2. So in your small table, you put -2 in there, put the -2 in for the x, see what y you end up with that goes along with it. -9. And there's another point. You've already got the intercepts. You've got a point -2, -9. Add that to your list. Try a 3 for y. See what x you get. It's that simple, really. Or if it isn't simple for you yet, just practice a little bit until it becomes second nature. And there are two more points. You already had the x-intercept and the y-intercept. This gives you 2 more points. Graph those and see what you've got. Now remember, it was x to the first and y to the first, so that tells you it's going to be a line, and all 4 of those points should be in a straight line. If they're not, you made a mistake somewhere. Go back and start over again, please. And there we go. There's the graph of the equation, y equals 4x minus 1. How about this one? Well, first of all, you notice that the square root tells you it's not a straight line. So you're going to need more than 3 points. You might need 5, 6, 7 even. And choose your y's carefully so this comes out as nicely as possible for you. If not, your calculator is going to help you find the square root anyway. Just use about 2 or 3 decimal places. You'll be in good shape with those x and y coordinates that you're putting together. This will give you a smooth curve, and it'll look something like this. Now, why does it look like someone chopped it off? That's because there are sometimes numbers you can't use. For example, if you look at the square root up here, you can't have a negative number under the square root. So the y minus 1 can't be negative. Another way of putting that is y minus 1, the number you put under the radical square root, has to be greater than or equal to 0. And all you need to do is solve that inequality, add 1 to both sides, and these are the y values you want to use. Put any of these y values in here, and you'll get x values that will match up with that. Here's another one. Notice it's x squared, so it's not going to be a line. So you'll need some more points. The good thing is, on this one, since you can square any number, any real number, you can pick anything you like. And back in the previous one, you were limited a bit with what y's you could use. In this, you're not limited. You can set up your personal table, pick 5 different x's, use this to calculate what the y coordinates are that go along with it, and graph it. So there are some points you could have chosen. Notice this is similar to what I told you before. When I'm picking x's, there are some negative numbers. There's 0 because it's going to be easy, and some positive numbers. That's why you've done different things with this equation in matching up the x's and the y's. Well, folks, that's about it, except there's the picture of the curve, and that one's called a parabola. We'll talk about that more later, but for the time being, that's a parabola. Notice these curves do not come back around. They keep going out both ways. Well, we'll see you later. Bye-bye.